Welcome back. In this video we'll take a look at this chapter, resolving and binding, and let's just jump right into it. Okay, so the first issue that we find is that there is some kind of problem in our variable resolving algorithm, which is this example where we have a global variable, then inside some inner scope we define a function that captures a variable, and then we call the function 2 times, and then the second time we have overridden we've made a new variable with the same name in the inner scope, and the problem is that this function thinks that here it should print this variable and not that one, whereas really it should, like here it should capture this variable and just always use that. And we can see that it actually does do the wrong thing, prints global and then block, which should just print global. Okay, so to fix this problem, basically there's different ways to do it, but we are going to build a resolver, which is something that will run in between parsing and interpreting, and it will, when you do the, it will look at the declaration and figure out which variable it should point to. And that way you will get around this, because when we declare this variable, then later when we declare this function later, once it runs through the resolver, it will look at this A and see that it refers to this one, and it will store that information somehow. And then anytime we call the function, it will already know which variable it should use. So let's try to do that. And it's quite interesting that he gives it an interpreter. I'm not really sure why it needs that, but I guess we'll see. So let's see, he uses this visitor pattern again, but we don't have that. Instead, let's try to make a function called resolve, which will undoubtedly have to be mutable. And the first one, and probably it needs to take, so we'll mark that as to do. I mean, whenever he's used the visitor, we've used this match thing. So let's do this. It gets like a syntax tree. And no, it needs, here it's a statement. And we can probably remove that for now. So if it is a block, then we will call, let's call it resolve block. And kind of annoyingly, I guess we have to do like this again. Then we'll do these functions, which probably have to be mutating, but beginner scope, then likely we are not gonna call this resolve thing. It's gonna be a different one. It's a dumb name, but let's do this for now. Resolve statements and end scope. Just gonna put wrong type. Okay. So the idea is that when we go into a block statement, we begin a new scope. Then we handle all the methods, resolve there, or all the statements, sorry, and resolve their bindings and so on. And then we end the scope. So let's try this one. Resolve many has some statements, which is a vector of boxes. And that's simply for statements. We need to, again, resolve that. So I'm kind of not sure how to implement this because the Java code is so different. But let's do something. So because let's do this, and this will likely change. So we resolve one, and this is using the visitor pattern as I understand it. So that will actually go back up to the visitor method. So actually we don't need this resolve one. It should be correct to do this. And then there's this function, whatever. Okay. So we need some, the really interesting behaviors around scopes. A new block scope is created like so. Okay, so now this type needs some scopes as well, and is using a stack. We should be able to just use a vector and then a hash map from string to boolean, and there we go. And I think we have to do something like this. Let's try to compile it. So first we need to add it in here. And we can check it. Is it really not called bool? It's called boolean. Okay, whatever. Right, and it doesn't like this because I have to do this and then I have to ignore it. And the real question is if we really want to have a statement, or can we do a reference to a statement? So this should be a reference. And right, now we just need to implement this begin scope and end scope. And this becomes a reference to. Great. The reason I want to use references is because I don't think we want to modify any of this, and we probably shouldn't take ownership. It's just more simple if you only use a reference, I think. So we made some, let's also make a new function. Which will make a new interpreter and an empty vector, because now in begin scope we can say scopes push hash map new. Great. So we have this new field which keeps track of the scopes. Each element in the stack is a map representing a single block scope. Sure. Keys as an environment are variable names. The values are booleans. Yes. The scope stack is only used for local block scopes. So then we will also have this end scope, which quite predictably called pop. Let's just check that the method actually exists. Good. And by the way, this pop returns an option. So I actually want to raise an error if we cannot pop, just because it should never happen. Okay, so now that we have these scopes built in, we can do something. And let's look at variable declarations. So let me see. It's just called var. So, and it has a name and it has an initializer. And we will call it resolve var, just to have this function itself like kind of clean. So resolve var. We can also do this if let var name initializer think, but of course it has to be statement var. And that's it. It's the same as this match thing, but kind of a different syntax. I'm not sure what I prefer. Okay, so now we need a declare function. and we will declare the name. And probably we want to clone it. Let's do that. Well, let's not do that. And then if, okay, interesting. And is this, no, it is a specific expression, cannot be none. Let me see down here. So that's interesting. I don't remember. Like if we don't have an initializer, we should support that. But what is, right, just checking. Yes, we support that. And it's just set to nil, which makes a lot of sense. But what is actually the value of the... It's probably just a literal. So let me just check that. We go into interpreter. We see what happens when you pass a variable declaration. And can we like print the debug version of the initializer? That didn't help. So let's go in here. Let's say, how about we call, let me do this. Yeah, so it is, not sure if we should actually change that, but anyway, it is just this literal value, which is, oops. If we go into the parser, then there should be like a declaration function. And yeah, so here we see it. If there's no initializer, we just put in like a literal value of nil. And actually, it should be okay to, so let's add this function that we don't have yet. So we can say match the initializer. And if it is a literal, then we don't need to do anything. We can just pass. If it is actually, maybe we just do like this. All right. And then we call define on the name, apparently. Okay. Let's so what are we gonna do? First, we're gonna declare it, which is like a saying that it exists, and then we're gonna find out how to calculate it from the initializer, and then we're gonna define it, which is storing how it's calculated in some way. Declaring, then defining auto-handle font edge cases like this. Okay, let's try to implement this declare function. So we need to mutate ourselves. We need a what's probably a token reference. So if the scopes stack is empty, we don't do anything, we just return, means we're in the global scope. And otherwise we will look at the last one in the scopes. And insert false. I'm not sure what false means yet, but let's run this. And we need to use create scanner token. And those errors are fine. So we mark it as not ready yet by binding its name to false. Interesting. So once it's been declared, then we run the resolution of the initializer. And once that is done, we can define it. So let's add the define function. And it's the same, except that this should be true. Okay, great. Now we just need this function. So that will be, maybe we put it up here. And let me, no. Anyway. So in the insert function just takes the key value, and I don't want it to take ownership of this data, so maybe we need to put a clone here. Are there any other functions? This insert, get, yeah, that's fine. So I just clone those, so there's no issue there. Now we do something. So if we have a variable expression, let me check what the name is again that we use. It is just a variable, and it just has a name. Then we do something. Let's use the same pattern. We're gonna have a lot of functions, but that's how it is. And maybe we put all the expression, yeah, maybe we do that. We put all the expression things on the bottom of the file. And what went wrong? If let's expr variable name, this one we can ignore. equal expo, then do something else, panic, wrong type in this function. Okay, then we will say if the scope is not empty and the last one, if we get, and here it takes, returns a reference to the value corresponding to the key. It gets a reference. So if then lexeme because it's going to get an option. How do we do that? We'll unwrap it for now. So if that is equal to false, I always hate writing Boolean equal to something, but whatever. Then we need to throw an error. Which we can do like we normally do. We have a result type. And I think it's probably best to keep that pattern. So let's start from here. Okay, I'm just going to do this. And let's mark this as to do. And then go on with fixing all the compile errors. So, use of undeclared type, expo, use create. Line 80. Right, so here this one has to also return this. And 89. Can we just dereference it? 23 has a warning, which is fine. Line 99. We'll mark it like that for now, just to get rid of the warning. So, really? Are you kidding me? Now there's some warnings, but let's see where this resolve expo was called. It was called up here. We should do that. To get a string out, string. Then we have the resolve var call up here, which should be that. And we'll do this. We will do this. And this. And we always have to mark it as okay now. It was great. Same here. And let's just try to get rid of all the warnings. That's it. Now I hope we're using all our result types. Otherwise it should have given us a warning. Anyway, back to the real business. So here we are checking whether the variable, whether this expression is trying to use an uninitialized variable. And then we return an error. Otherwise we try to resolve it. So let's see what that does. It goes through the scopes in backwards order, which makes a lot of sense. So let's say for scope in self.scopes, eta reverse. And then we will say we have contains key. If scope contains key, and we have to say if let again. It's not great. So panicking here may not be the right thing, but we will see. Right, so this, and then we need one more. Okay, so if we have this, and is it a reference? What does it want? Yes, it wants a reference. Maybe it's already a reference. Let's try to do that. Then it's calling resolve for the interpreter. Damn. Now we also need the index, so let's say from 0 to self scopes size -1 reversed, and then we plug in something very weird. But whatever. We have to remember that if we find a scope that contains it, then we just interpret it and return. And how's our interpreter? Likely the resolve function on that will also return. And a result type. So we do this thing. So the point of this is to store how many times do you have to go back before you find it. If that makes sense. So if it gets a value and it's like if it's 0, then you should evaluate this expression using the this variable using the current scope. If it's 1, you should use it. You should evaluate it using the previous one, and so on. Okay, so let's. Otherwise, you say it's okay, because you assume it's global. Okay, now let's see. Now we need to handle assignments. And assignments, they have a name and a value. So let's put it down here. By the way, no, that's fine. So if let expr assign name value equals expr, then do something else we panic. Wrong type in resolve assign, and let me fix this one. And here, make an extra space. Okay. And again. All right. So the value is a boxed expression. So we'll say resolve. And it's calling resolve, which ends up where? It ends up in the visitor method, if I remember correctly, so we need to call resolve. exper, and it's a box, so we need to call as ref, and then resolve local of the name, and that is also an error, so we do that, and that one we don't need. Okay, 123, I forgot that, so say scope, self.scopes of I, and here we need to do this, and here we need to do that, and this error is fine. And let me see, resolve local takes an expression. But here we're giving the name, so that's wrong. Let's give the expression. Ha. But that means that it would be okay if this okay, so now I get why we take the name, which is a token, and we don't want this if let, probably. It looks horrible. Okay. So that's great. Do that. And we check it. And we need to update the call up here. And now we just have that this resolve method on the interpreter is not defined, but that's fine. But actually, I think we'll stop here for now, because it's quite a long video already. But we're well on our way to having a resolver. So see you in the next video.